Everyone, welcome to Tech Gyani. So today we'll be discussing about a problem called decimal to binary conversion using bitwise operator. So without using the normal conventional array method, we'll be discussing about how to solve this using bitwise operator. And let me tell you that this approach is actually faster than the array method. Okay. So because this approach is going to get a faster value, so we'll be using this bitwise operator method, right? So before starting how to solve this, so let's build a function. Okay, so public static void, you can say, sorry, decimal to binary, right, and in, right. Now what will be the logic, right? What will be the logic? So suppose I am taking a value called 15, right? So 15. So we'll be taking this value 15, and we have to get the output of the binary representation of this number. This is in decimal. Now we have to get the binary representation of this number, right? Always remember the binary representation. In binary representation, the number of bits is 32. In binary representation, the number of bits is 32. So what will be the number? That number will be consisted of 32 bits, or it will be in the range of 32 bits, right? So if we take 15 as binary representation, then the value of the binary representation of the 15 will be in the range of 32. So what we can do that, we'll be taking 32 times loop. So if we're taking the for loop, and we'll be running the loop for 32 times, and we'll be checking that if this condition is going to, and that condition will be discussed in this function. So we'll be discussing that. So before that, just remember that we have to take a loop for 32 times, and we have to check the condition of binary decimal to binary conversion, and we will be getting the output. Okay, so as discussed, so let's take for int I equal to 31, because we'll be taking the I as 0 for the initial value. So I greater equal to 0, right? Then we'll be decrementing the value, because we will be getting the value in reverse order in the binary representation. Always remember, we'll be getting the output in reverse order. Otherwise, we'll not get the right output, right? Now, what we'll do that, uh, we'll take a variable called result, and we'll store it. So in this result variable, we'll be doing the condition is that, so we have taken the value as n. So n right shift I. Okay, so this condition, int result equal to n right shift I. Okay, so this loop is actually running through 32 times. 32 times it is running, and it will be shifting the value of n. It will be right shifting the value of n for 32 times. Okay, so suppose if there is a value called, suppose I am taking the value as 32. So what will do that, first loop, second loop, third loop. Okay, so at that time it will shift the bits of this number. So if there is, suppose there is a bit called 1, okay, in the initial. Now the right shift operator will do that, the 0 will be appended in the left. So 0 0 0 0 0 0 0 0, it will be continued to 32 times. Okay? 32 times. So this 0 will be for 31, and then it will be 1. So 32 times this 0 will be appended, and that is called the right shift. Okay, that is called the right shift, and this operator is actually doing that. Okay, so this is the first condition. Now what we will do that, we know that in AND condition, okay, in AND condition, 1 into 0 is equal to 0, right? And or you can say 1 and 0 is equal to 0, and also 1 and 1 equals to 1. Okay, so we'll be doing that exact same in this approach. So suppose now, okay, so there is something error here. So if result and 1, if result and 1 is greater than 0, then we'll print system.out.print 1, right? And else system.out.print equal to 0, right? So what we're doing that, suppose this value, suppose after right shifting the value, we getting the value right 0 0 0 0 0 0 0 0 0 0. Okay, now there is a n value. Okay, so as you have taken the value of n, so I am discussing with n. So suppose this type 31 times this 0 will come, and then n. Now we'll be taking the value as and then 1. Okay, so now depending on the n value, suppose n is 0, right? So this 0 and 1, we know that 0, so we'll be getting the output as 0. But if n equal to 1, then this 1 and 1 will get the output as 1. So at that time, we are reversing the order, then the binary representation will come like 1 0 1 0, such like that, depending on the number. Okay, so always remember that 1 and 0 is 0, 1 and 1 is 1, and that is actually happening in this condition. But always remember that we have to right shift the value such that it is getting the condition and it is getting the AND operation with 1. Okay, so this is all about. Now if we clear this, now this else system.print 0, then this loop is going to close, this loop is going to close, and now we will just call this function, right? Suppose we are taking the function, and suppose we are taking the value as 15, right? So let's see if this works or not. So this will be I. Okay, this will be I. Okay, is there any error? So let's run it. Okay, so what is it is telling that, okay, so this will be intent. Okay, yeah, so let me clear the console, and that is the run code. So this is the binary representation of this number 15. So let's verify it. So binary representation of 15. So this you can say the 1 1 1 1, and you can see this value has come. Now this like with the 0 0 0 0 have come because of the right shifting value. Okay, so the value will be like that. Okay, so this is the actual code, and this is all about. I think this video is going to help you in the placements exams also. So please, if you like this video, please like and subscribe my channel. Till then, goodbye.